Now that we have our two parts, it's time to build a connector. So I've come up with a connector that works really well based on hexagons. So I'm going to start a sketch on here, and we're going to make some male and female pins. You can use your imaginations and why they're called male and female, but it's an industry standard for electronics, and I sort of adopted it here. So we're going to go to our polygon tool, and we're going to draw out. Oh, and we're going to go 6. Now the reason I do a hexagon is that I can make this side and this side. This will print flat. This will print flat, and these are nice steep angles. They're easy to print, but provide a lateral protection from decoupling. So these print very nicely. They print easily. Most printers can handle them. And the only thing you have to really worry about when you're designing this is the tolerance between the male and the female, which we'll talk about on the next sketch. So let's get this guy finished up. If I remember right, I kind of want to go a little distance in from here. So maybe a 0.5. I said 0.5. And now we're going to extrude that. And we'll go like 0.5. That looks reasonable. I'm going to run a chamfer around all the edges of a 0.05 chamfer. This helps with mating the two pieces. Again, those print at 45-degree angles. They print really well. So that is a male connector. Now let's build a female. So let's start a sketch on here. And then I guess I'll just leave it upside down because it doesn't really matter. This time I'm going to use construction mode to draw this guy. And I go, there we go. And now we're going to lock him just like we locked the other one to the two sides. So this can go, this can't move, it just move back and forth. I'm going to project as a construction this line guy here and put a line down the middle of him. I don't know why all my parts are male, but I'll fix it one day. So this to here. And I typically use 0.375, which is half of 0.75, which is the spacing I typically do. I found it works well. So if it's not broken, why fix it? So now we're going to use our offset tool and not in construction mode around this. Except instead of 0.25, we're going to do 0.005. Now, this tolerance is dependent on your printer. You might have to do some test joints to see what works well. That gives you a nice tight fit, not too loose. 0.05 tends to work pretty well. I can even go as low as like 0.004 or 35. And then sometimes I have it here, I'll go to 0.04 because I want this fairly tight. It's not going to come apart once I'm done. And now we're going to extrude, but this time we're going to cut inwards 0.51. So just a little deeper than this out. So that I definitely don't collide and they'll meet really well. Now I need a bunch of these. So we're going to use a pattern. And I'm going to do a feature pattern. And I'm going to grab extrusion 2, chamfer 1, extrusion 3, and the direction I'm going to pick is along this edge. Do extrusion 1. Oh, not extrusion 2. I want. Apply per instance. Yeah, there we go. And then we're going to usually flip the direction. That looks better. And let's see the distance should be 0.75. And I'll do, and right now I'm going to look at it from the top so I can see this edge. I don't want to go past this point. You'll see why in a moment. Let's go 6. I think we're off 5. So now we have that. Now we can take and mirror our pattern. Feature mirror. The linear pattern. And apparently we also need to give it extrusion 3, extrusion 2, and chamfer 1. And the why is it going that way? All right, I'm going to mirror extrusion 2, chamfer 1, extrusion 2, and then the linear pattern. It doesn't, Onshape apparently does not handle linear patterns properly when you're mirroring them. Good to know. So we're going to get rid of the linear pattern, to check, and then we'll just linear pattern that side too. So I'm going to linear pattern the mirror feature pattern. The mirror direction is going to be this way. Apply per instance, flip direction, 0.75 and 5. And that's going to give us a really strong connector between the two sides. This gap in the middle is not going to affect anything. But before anything else, we're going to do the same thing on the other side, except starting female instead of male. But let's export this and make sure that we have a part that will actually work on Onshape. F11. Let's put in proof slicer and see if we can make this fit. We might have to move that first joint in a little bit. There we go. That prints A-okay. Print time is a little long. Let's go to lower quality. We're doing it 4 hours, but we should have a nice strong connector on this. If you are worried about curling, you can put a berm on here. You just have to take and clean those up afterwards. You might be careful of the berm pushing you over the edge, which it does in this case. I'm going to go without berm. I'm feeling fairly safe about these. I am going to have to go and do a print settings, skirt and brim, and remove the skirt. And that should bring me back to happy land. Yep, we're good now. So it fits barely. And I could play with the sizing and try to push it to the edge a little bit, but that works fine. So now it's time to do the other half. So let's go and do the same thing. I'm going to hide this so I can see it. Run it back, and I'm going to start a sketch on there. And then I'm going to draw a hexagon. So this is going to be a constructed hexagon because this is going to be the female. And sorry, inventor, you pick the number of sides first, so I keep having that problem. F11 so you can see everything. All right, that looks good. I believe the center of this guy, if I go back to front, this first sketch was 0.5 away. So for the center to here is 0.5. I'm now going to do my offset. And we're going to do 0.004, enter, point, extrude, remove, 0.51, just a hair longer. We will have a little gap, but that's not a huge deal. It doesn't cut through the edge. That's the other thing we have to look for. That looks good. And now let's start doing the other half of this. So sketch, look at it, project geometry, draw our hexagon, not construction this time because it's the male one. Every time. And now I'm going to go and horizontal this, and I'm going to connect this point to this line, and little dimension. I'm going to project as a construction this guy here. I'm going to draw a vertical line through the middle. Dimension from here to be 0.375, which is 0.75 divided by 2. I probably could go with a different measurement of a go 0.5, but I've just been using it for so long now that it's habit, and I know these work really well. So all the shelves I design for that are larger than my printer, I use this type of joint consistently. And once you have a tool that works very well, why change it? So there's that. Check. I'm going to linear pattern, extrude 2, extrude feature pattern, apply per instance, direction, 0.755. This just has to be the same setting as the other one. Now I'm going to go to the same, I'm going to take and mirror it. I'm fairly certain we can only do extrusion 2, extrusion 3, feature mirror, extrusion 2, extrusion 3, chamfer. Mirror plane is going to be there. Let's add the linear pattern, see if we'll do it. Nope. So we'll do that. And then linear pattern, mirror 1 as a feature pattern. Direction is going to be there. Apply per instance. Oh, that one. Direction. I need 0.755. And now we have a very good fit. We should do a quick, let's export this to make sure he'll print. So export. Go, I'll tab over to there. Open our copy of it. Having 2 copies of Proof Slice Open is very helpful. Just make sure you have something right. So before anything else, we'll put this to draft. Let's add the object. Okay. And that prints even with the skirt. So 8 hours for the 2 pieces. So 2 prints, 1 4 hours, 1 8 hours. And I'll have that done. And these should connect together really well. I typically like a infill of concentric on these, just because it sort of gives a nice pattern. Same thing, this one. Print settings, top infill, concentric. And that looks really nice. And I should do one last thing, which is do an assembly test. So let's insert our 2 parts. Check. And because they seem the same area, it actually puts them together right away. But if I want to mate them, I can use a fasten, and I can use the very center of this surface, glues to the very center of this surface. Check. And yeah, you'll have these little air gaps, but they are small and they won't look bad. And now we should have our thing. I'll probably print the shorter one first, and then assemble them, and I'll show the final video of the assembly.